Good morning students, my name is Mallika, PGT Physics in DORNALA. Today we are going to discuss the topic is Huygens principle. Assume two laws of propagation of the wave through the water or on the surface of the water. Nothing but crust propagation. If you observe this point of disturbance around it in a circular shape, these all wavelengths will be created. These all wavelengths will be created. The disturbance travels to forward direction. What we assume in this case is all the wavefronts are the source of initial wavefronts. All the wavefronts are the source of initial wavefront. Primary or initial wavefronts are the source of secondary wavefront. Primary or initial wavefront are the source of secondary wavefront. The wavefronts traveling with the speed of all directions following the symmetry. The wavefronts traveling with the speed of all directions. All wavefronts moves tangentially to the forward direction. Why it is said to be tangential? That means surface is like this. Tangential means to touch propagation towards the end. To touch propagation is towards the end. This arrow indicating tangential. The circle, this is all the circle. The circle created wavelet. The circle created wavelet. These circles are wavelets. These circles are wavelet created by wavelength to produce secondary wavelet. That means n creates n plus 1 wavelet. For example, n is the primary or initial wavelet, n plus 1 is the secondary wavelet. Such that the Huygens principle with their assumptions are postulates. Such that Huygens principles with their three assumptions are postulates. Three assumptions are postulates. Huygens principles have different applications of propagation of light. First application, diffraction of light on a plane wave. First application, diffraction on a plane wave. Diffraction on a plane wave. Diffraction of light on a plane wave is divided into two parts. First one, rarer medium to denser medium. Second one, denser medium to rarer medium. If we check these two examples. Next, second application, reflection of light on a plane surface. In these two cases, we check what are the changes in velocity of light, what are the changes in direction of propagation of light, and behavior of medium. Now we are going to discuss refraction on a plane wave. Refraction on a plane wave. We are assuming the light which was incident on the surface as a plane wave. Let us take a surface. This surface is indicating P dash. Above the P dash surface is medium 1. Here nothing but air. Nothing but air. A light started at a point A dash. Yet incident on a point. On the surface P dash. One which is partially reflected on the same surface or same medium is called incident wavefront. Incident wavefront. The instant light makes an angle is called incident angle of incident, indicating I. Here angle of refraction is indicating R. Here medium 1 is a rarer medium. Medium 2 is a denser medium. In this case is called known as rarer medium to denser medium. Rarer medium to denser medium. We draw the normal towards the point is called refracted wavefront. The incident wave create an angle. The incident wave create triangle A, B, C. The refracted wave create triangle A, E, C. Here two triangles is in there. First one instant wave create triangle A, B, C, and second one refracted wave create triangle A, E, C. Triangle A, E, C. Here V1, V2 are here. V1 velocity, instant wave traveling with velocity V1 and the diffracted wave traveling with velocity V2. Here V1, V2 are the rarer and denser mediums velocities. V1 torque. Torque is the distance between B to C. Distance is equal speed into here time indicating torque. Torque is nothing but time. And V2 torque is the distance between A to C, point A to E. Instant wave create a triangle A, B, C. Triangle A, B, C. This is incident wave. That's why sin angle I. Sin I is equal sin theta formula. Opposite side by hypotential in trigonometry. In trigonometry, sin theta formula opposite side by hypotential. Opposite side means BC by AC. BC means V1 torque by AC. This is called equation number 1. From triangle AEC is refracted wave. Triangle AEC. This is refracted wave. That's why angle is R. R is equal opposite side by high potential. Opposite side means opposite side by high potential. Opposite side means AE, high potential is AC. AE by AC. The distance between point A to E is V2 torque by AC. This is called equation number 2. From equations, this is called equation number 2. From equation 1, dividing equation 1 by equation 2. That implies sin I by sin R is equal V1 torque by AC by V2 torque by AC. Sin I by sin R is equal V1 torque by AC into this denominator fraction V2 torque by AC. This fraction will be interchanged. AC by V2 torque. Here AC term, S term cancel, and torque time term cancel. Sin I by sin R is equal V1 by V2. This is called equation number 3. Simplify these equations by assuming the condition. We got sin I by sin R is equal to V1 by V2. We know that refractive index is equal speed of light in air by speed of light in given medium. Here refractive index is indicating by the letter N. So in case N1 is equal to C by V1 and N2 is equal to C by V2. Here N1 means refractive index. N1 means refractive index of the medium 1. N2 means refractive index of the medium 2. In such case, now from this expression, I got V1 by V2 value. So that's why N2 by N1 is equal, N2 means C by V2. C by V2 by C by V1. This implies N2 by N1 is equal C by V2 by C by V1. This implies N2 by N1 is equal C by V2. Here this denominator factor will be interchanged. That means V1 by C. Here C term cancel. Now substitute this value in equation number 3. We got equation number 3. This implies sin I by sin R is equal to V1 by V2. This term will be is equal to N2 by N1. So N2 by N1. Sin I by sin R is equal N2 by N1. Cross multiplying it. N1 sin I is equal N2 sin R. This equation is called Snell's law of refraction. This equation is called Snell's law of refraction. The ratio between the wavelength of incident wave by refracted wave. That means wavelength of incident wave by refracted wavelength. Lambda 1 by lambda 2. Lambda 1 means medium 1, medium 1's wavelength. Lambda 2, medium 2, second medium wavelength. That is equal to, in medium 1, distance between B to C is V1 torque. V1 torque by medium 2. Distance between A to E is V2 torque. Here torque term cancel. This implies lambda 1 by lambda 2 is equal to V1 by V2. Cross multiplication it. Cross multiple it. Lambda 1 V2 is equal V1 lambda 2. Lambda 1 by lambda 2 is equal V1 by V2. When light travels from rarer medium to denser medium, wavelength and speed of light is changed, but not frequency. Next case in Huygens principle is let us take a ray which is traveling from denser medium to rarer medium. Here medium 1 is called denser medium, medium 2 is called rarer medium. If a light ray traveling from medium 1 to medium 2, medium 1 is called denser medium, medium 2 is called rarer medium. If light ray which comes out of secondary wavefront is emergent angle. If the light ray which comes out of denser medium is called emergent ray. According to symmetrical geometry, the angle of emergence is equal to angle of incidence. Angle of emergence is equal to angle of incident. According to symmetrical geometry, angle of emergence is equal to angle of incidence. Light is incident at second end of the denser medium with the angle of incidence is I, and it will refracted away from the normal point A. It will refracted to E. This E, if you draw another normal which will give refracted wavefronts. Time taken. Incident wavefront is V1 torque. Time taken. The refracted wavefront is V2 torque. We know that sin I by Sin, we know that sin I by sin r is equal to n2 by n1, and n is equal to c by v. Here n is refracted, n is equal to refracted index. Refracted index n is equal speed of light in air or vacuum by speed of light in given medium. This medium one has greater refractive index, and in this case speed of light is less. n2 less than n1, but speed of light v1 less than v2 or v2 greater than v1. Refracted ray that comes out of the denser medium. There is the angle. That one angle is called critical angle. Critical angle means the angle of incidence yet the entire angle of refraction becomes 90 degrees. Refraction becomes 90 degrees is called critical angle. In this case, sin r is equal sin IC. IC means critical angle in instant wave. Sin r, refracted wave, becomes 90. Sin 90 is equal sin IC. In Snell's law, sin I by IC by sin 90 degrees is equal n2 by n1. In trigonometry, sin 90 value is 1. So that's why sin IC is equal n2 by n1. This is also written as IC is equal to sin inverse of n2 by n1. Thus, when light is instant at greater, light is instant of greater. When the angle of instant I is greater than critical angle, there will not be any refracted wave. The wave will undergo total internal refraction. Our next topic is interference of light waves and experiment. Interference. One definition of interference: two light waves trying to overlap on each other. There will be a wavefront or wave pattern can be observed. This phenomena is called interference. This interference can be produced by two different techniques. First one, amplitude. Amplitude splitting. Second one, wavefront splitting. What we can understand is Young's double slit experiment is prove the both. Young's double slit experiment. This is a sub-concept or one of the demonstration of interference of the light. Interference of light. For this purpose, if we take if we take a slit, source of light is just behind this slit. This source of light at this slit. This is source of light. At this source of light at this slit. Splitted into two parts. Whenever this splitted one passes like this to another small slits. So it is screen. On this screen we should have the dark and bright. We should have bright fridges and dark fridges formed. What we understand from this pattern is this source of light when passes through a slit, its amplitude is uniformly distributed in a form of wave. This is amplitude. This is amplitude splitting. When amplitude split pass through, when this amplitude split passing through two narrow slits, whenever these two waves are overlapped on each other, same phase will arrange the bright and dark fringes. Now we are going to find the optical path difference between the waves with respect to a common point. Let's take a surface of light. Let's take a source of light here. This source of light will emit the light. This light will traveling through two slits, S1 and S2. S1 and S2 are two slits. P to F is the screen. The distance between two slits to screen is capital D. The distance between two slits is small d. These two lines will interference the point P with respect to common point. This common point P takes a triangle with respect to the source S1 and S2. For that purpose, we should go back to the trigonometry calculations. Here, at S1, at S1 light is at S1 the light incident at point P. For S2 from S2 light slits with from S2 light was splitted and another light to convergent point S2P. From S2 light was split and another part of convergent is P at with instant at S1. Draw a perpendicular from S1 to the S2P ray. From a perpendicular, draw perpendicular from S1 to the light ray S2P is making an angle theta. Yes, S1 and S2 choose a middle point M. From this, I draw a straight line from this point O. Here, O is the middle point of the source. The distance between P to O is x, and the distance between P to O is x, and the distance between E to O is d by 2. The distance between O to F is d by 2. In such cases, what we understand? We should find out the path difference. The path difference is nothing but S2P minus S1P. Here S2P F is one triangle. From triangle S2P F, we should follow the Pythagoras principle. That is, S2P whole square is equal S2P whole square is equal S2F whole square plus P2F whole square. S2P whole square is equal S2F is the distance between the screen. That's why D whole square plus P2F is the distance between P2O plus O to F. P2O plus O to F. S2P whole square is equal D square plus the distance between P to O is x. The distance between O to F is d by 2. This is called equation number 1. From triangle S1P E, we should follow the Pythagoras principle. S1P whole square is equal S1E whole square plus P1E PE whole square. Here S1P whole square is equal S1E is a distance D whole square plus P2 is X minus D by 2 whole square. This is called equation number 2. From equations 1 and 2, the path difference S2P whole square minus S1P whole square. S2P whole square is D square plus X plus D by 2 whole square minus D square plus X minus D by 2 whole square. That implies D square. This is A plus B whole square form. That's why X square plus 2 into X into D by 2 plus D by 2 whole square minus D square plus X square minus D square plus this is A minus B whole square formula A square minus 2AB plus D square X square minus 2 into X into D by 2 plus D by 2 whole square. This implies D square plus X square plus this numerator part denominator part cancel. XT plus D square by 4 plus into minus minus D square plus into minus minus X square minus into minus plus the numerator denominator will be cancelled. XT plus into minus minus D square by 4. Here plus D square minus D square term will be cancelled. Plus X square minus X square term will be cancelled. Plus D square by 4 minus D square by 4 term will be cancelled. Here XT plus XT is 2XD. STP whole square minus S1P whole square is equal 2XD. We can write this is S2P minus S2P plus S1P into S2P minus S1P is equal to 2XD. 2XD. This is A square minus B square formula. A plus B into A minus B version. We know that S2P and S1P is same distance or equal surface. Now S2P is, let us assume S2P is similar to S1P is equal to distance T. Now substitute this equation. S2P is capital D plus S1D is capital D into S2P minus S1P is equal to 2XD. D plus D is 2D. S2P minus S1P is equal to 2XD. Here why we put D is total distance, that's why 2D. S2P minus S1P is equal to XD by 2D. Term will be cancelled. S2P minus S1P is equal to XD by capital D. So in the interference we got S2P minus S1P is equal to XD by capital D, small d by capital, where D is the distance between the slits to screen. From this equation we got the normal condition for bright fringe to dark fringe. Now we will applying the same condition of the path difference for denser medium to now we will applying the same condition for the bright fringe to dark fringe. Bright fringe will occur due to the addition of the intensity of the two light waves which are moving in same phase. In case path difference is equal m lambda. M is the order of fringe. M is equal 0, 1, 2, 3 and so on. Lambda is the wavelength of different amplitudes and different intensities, but same in phase. That's why wavelength also added. That's why it is not subtraction of the wavelength, it is addition of the wavelength. It is a function and normal and integral multiple of m. XT by capital D is equal m lambda. Here lambda 1, 2 lambda, here lambda, 2 lambda, 3 lambda and so on. All orders are formed. Next concept, dark fringe. Due to the overlap of two light waves, intensities I1 and I2, which are moving in opposite direction. This is in upward direction, indicating downward direction. Total wavelength is lambda by 2. In dark fringe, path difference is equal to 2m plus 1. 2m plus 1 into lambda. Here m is equal 1, 3, 5 odd numbers taken. M is equal to 1. Path difference XD by capital D is equal to 2m plus 1 into lambda. XD by capital D is equal to 2 into 1 plus 1 into lambda. That is called 3 lambda. Path difference is equal to 2m plus 1 into lambda by 2. Here m is equal to 1, 3, 5. M is equal to 1. Substitute m value in this path difference. XD by capital D is equal to 2m plus 1 into lambda by 2. XD is equal to 3 lambda by 2. Here wavelengths are 3 lambda by 2, 5 lambda by 2. This like came. Here odd terms are coming. Fringe width. Fringe width is defined as the separation of one bright fringe to next dark fringe. That means The gap between the consequent of bright and dark fringes is said to be fringe width. Fringe width definition. Fringe width definition. The distance between the bright fringe to the next dark fringe is called fringe width. It is represented by term x. We know that x d by capital D is equal m lambda. From this x is equal m lambda d by small d or m d lambda by small d. This x applying the mth fringe. X m is equal m d lambda by small d. In this case, from the next fringe, x m plus 1 is equal m plus 1 into lambda d by small d. So, fringe width beta or capital X is equal x m plus 1 minus x m, that is equal x m1 please m1 plus lambda d by d minus m lambda d by d. Now we are common lambda d by m plus 1 minus m into lambda d by d. Here these terms are cancelled. Beta or fringe width beta or x is equal lambda d by d. Lambda is the wavelength of the slit, d is the distance between the slit, capital D is the distance between two slits to the screen. In this, fringe width is directly proportional to the source. In this case, here three cases are there. First case 1, beta is directly proportional to lambda. This means fringe width is high. Here wavelength of source value will be high. Fringe width decrease, wavelength of source will be decreased. Next case 2, beta is directly proportional to capital D. Capital D means the distance between slits to the screen. Here fringe width value is high. This beta value will be, this D value will be high. Beta is directly proportional to slits distance. Here beta value is high. Beta is inversely proportional to 1 by D. Here beta value is high. Here distance value is low. Distance value is high. Beta value is low. They are inversely proportional to total distance in slits. With this help, scientists have done many experiments by lambda d, small d values, lambda, capital D, small d values, different patterns of the scales. Different patterns of the scales. I hope you are understand these concepts. Thank you, students.